Okay, so everyone, welcome to our second day of our Tech Week event made from AvenueCoders to AvenueCoders and also some clients and some people that got invited to join our Tech Week. I would like to thank the participation of everyone that's on this call and everyone that's joining, and also thank Kaká for being our speaker for today. So today we're going to have a talk about it's about blockchain and development. Oh, sorry, second. About blockchain development and Web 3.0. So Kaká Oliveira will be the one that's going to present to us the talk today. If you're joining, you're going to see on this image, we have a QR code here, so you can check in your presence and also give us the feedback for the talk and for the event. And along our talk, I'll also be sending the links on the chat so you can confirm your presence and give us the feedback, okay? So one more time, our talk today is blockchain development and Web 3.0, and Kaká Oliveira will be our speaker today. Kaká, I invite you to share your screen and you can start your presentation.
Okay, thank you, Pedro. Okay. All right, can you guys see it?
Yes.
Yeah.
Yep.
All right. So as Pedro mentioned, we're going to talk about blockchain development and Web 3.0. I am Kaká Oliveira. I'm a principal software architect at AvenueCode. Just a small disclaimer. As blockchain and Web 3.0 is a very wide topic, I'd like to say that we're going to talk mostly about the development aspect of the subject. We're not going to go too much into the financial aspect and cryptocurrency subjects and NFTs and so on. And it's important to point out that we have a very interesting NFT talk tomorrow. So stay tuned for that. But yeah, we're going to talk mostly about the development side and how to develop smart contracts, what are smart contracts and smart chains and so on. All right. My keyboard is a bit buggy today, so the slides may hang a little bit. All right, talking just a little bit more about myself. I'm a software development. I've been in the technology field for the past 20 years or so. I started very early in my career when I was about 14, 15 years old, and I've been working with, especially with software development since then. Yeah, I work. I used to have a software house, a small software company, and this was a big part of my career and the time span of my life where I learned the most about the market, the technology market, and I had the opportunity to use many different technology stacks and become kind of agnostic when it comes to which technologies to use or to basically I have interest on any kind of technology, and this is one of the reasons why I had a huge interest on the blockchain technology since its first appearance on the years 2008, 2009, especially when the Bitcoin boom happened around those years, and that's when I started to this technology started to attract me. But yeah, we're going to talk about we're going to have 5 different topics, special topics. The first one is blockchain and smart chain. What is the difference between the two? What are the use cases for each one? The second one is a brief history of the web. We're going to talk about the early years of the web, how it used to work, how it works today, and how it probably is going to work and what it's going to look like in the future. So the next point is Web 3.0. We're going to give a lot of focus on this specific version of the web, let's say. Later, we're going to talk about decentralized application development, which is basically how the Web 3.0 works. You have decentralized applications or dApps. If you start to study about Web 3.0, you're going to hear people use this term a lot, the term dApp or decentralized application. And we're going to understand how those applications work and how they are developed. And then I'm going to point out some material, some studying material, so you guys can keep studying about the subject, and so you guys can acquire expertise on, especially on the development aspect of this technology. All right, so let's jump right into it. Let's talk a little bit about blockchain and smart chain. All right, blockchain. We have a little quote here, Bitcoin, the end of money as we know it. This was the promise of Bitcoin when in the early days, and maybe it's not exactly the same promise anymore, because the crypto market and the crypto technologies developed, the blockchain technologies developed a lot since the appearance of Bitcoin. And a blockchain is basically a distributed ledger, you know. Why do we use the term blockchain? It's because that's exactly what it is. If you look at the image, you have a block that is connected to other blocks before it and after that. Those blocks are basically containers of information or containers of transactions. On the Bitcoin use case, it's exactly what it is. You store transaction information on those blocks, and you have distributed nodes on the network. I'd like to have, I could have added a better diagram here to explain, but I didn't want to go so deep on the inner workings of the technology, because we're going to talk mostly about development. So, but that's basically how it works, and it allows secure transactions between wallet addresses. So you have an address, your friend or the company or whoever you're going to send money to has another address, and you can send money between those addresses, and the network is going to be in charge of validating those transactions and making sure of the integrity of those transactions. The reason why it's secure is because it's the blockchain is a distributed machine. It's not centralized. It doesn't have a single point of failure. The transaction is executed by all of the nodes in the network. You have thousands of different computers which have an entire copy of the blockchain, and all of those computers run the same operation. So if you compromise one of the nodes of the network, it's going to be decommissioned by the other nodes, because the entire network has a consensus mechanism to guarantee the integrity of the data. So just a comparison between the client server model and the blockchain or decentralized model. On the client server, we have a central server. Let's say if you're using Facebook, for example, Facebook has a centralized data center in a specific geographic place, in this case, in the Palo Alto city. You have a centralized server, and the clients access that server remotely, and it has a few advantages, but also many disadvantages. Like it's a single point of failure. It may not be the case if you have a distributed architecture, a geographically distributed architecture, but it is in no way comparable to a really distributed network like a blockchain. And in the blockchain, as opposed to the client-server model, you have a network that is composed by the users themselves. You can run a node, and you're going to become a part of the network. You know, each node of the network represents has a copy of all of the data in the network. So you're basically the network yourself when you run a node. And it has many advantages, as we're going to see later on. But yeah, this is basically the difference. It's a very simple diagram, but you can understand the difference between the two very clearly. All right, the advantages of blockchain over client-server model. Let's take the case of, for example, a banking platform. Transaction time is very reduced comparing to the traditional client-server model that banks use today. You have transparency over the transactions because you can just go to the blockchain viewer and see the transactions, all of the transactions inside of the blocks. You can see how much money, how much value a certain address sent to another address. Everything is transparent. It's decentralized, of course, as we already talked, and you have much more information security than in the traditional model. For example, in the current banking model, where you have a centralized server and the entire architecture is based on the client-server model. It's secure because no one can manipulate the information on the network. If you do that, as I told you before, probably the node you are tampering with will be decommissioned by the network consensus mechanism. All right, so about smart chain, we have this little quote, Ethereum network, the catalyst of the revolution. I like this quote very much because that's exactly what the Ethereum network is. You guys probably heard about Ethereum before, and most people think of Ethereum just like a cryptocurrency, but it's much more than that. The Ethereum technology is actually a very complex network that allows applications to run inside of the network itself. So, in the traditional blockchain, for example, the Bitcoin blockchain, you can only make transactions. The only use case for the network is to send transactions from one address to another. But in the smart chain, it's different. And Ethereum introduced this concept of smart chain, where you can actually run code, run programs inside of the network. And this gave life to a lot of different business models and use cases that we're going to see later on. So another key characteristic is that it allows many cryptocurrencies to exist inside of the same blockchain. For example, inside of the Bitcoin blockchain, you only have Bitcoin itself. But inside of a smart chain, you can have infinite different cryptocurrencies or crypto tokens, as we call them. Just because they're basically smart contracts, and you can deploy infinite smart contracts on the network. So some advantages of the smart chain. The smart contracts allow an entire new ecosystem of applications and business models. For example, some very common ones are DeFi, or Decentralized Finance. This is one of the most widely known use cases for smart chains. And you can have decentralized marketplaces like OpenSea, for example, where you can commercialize, sell, and buy NFTs and so on. And the smart chain is the great breakthrough that allowed the emergence of Web 3.0. because without a smart chain, you could not have a decentralized application architecture like Web 3.0. So some key getaways about smart chains, just so we can start understanding smart contracts. They run inside of a virtual machine that we call the Ethereum Vm. And the Ethereum Vm is a Turing complete computer. Many of us may not be familiar with the Turing complete term, but it's basically a computer or a language that can perform any kind of computation and solve any kind of computational problem, basically. And it gives a lot of flexibility to smart contracts. So you have a very powerful VM that can run basically any kind of application inside of the blockchain. All right, so I'm going to give you guys an opportunity to ask questions now about this specific blockchain topic, because I know it's a lot. So if you have questions, feel free to ask.
I have one question about blockchains. Kaká, how blockchains are faster than the client server architecture? I mean, the consensus between all nodes from the network doesn't require a lot of computing resource?
Yes. It's not faster than the client server model in that sense. But in the example I gave, I was talking about banking transactions, for example. To send an international transaction, let's be more specific. Banks usually take hours or even days to send a transaction between two countries, for example, because of not only regulation, but technological limitations between the tech stacks that different banks use or different technologies that banks use. As on the smart chain or blockchain, you can have virtually instant transactions in comparison to the time delays that banks have. So it's mostly on that specific example. Of course, you have a consensus mechanism that requires all of the nodes on the network, or at least a limited amount of nodes to validate the transaction before it can considered valid. It can be considered valid. So it takes more time, of course, than just making a request to a server and executing something on the back end. So in that sense, you're right. It's a bit slower than the traditional client server model. But one thing that is interesting is many development groups are trying to make this technology faster, are trying to create faster blockchains. There are many forks of the Ethereum project that try to solve those problems, not only the speed of the transactions, but also the prices, the gas fees, and a lot of other problems that a decentralized architecture brings. So it's a work in progress, and probably in the next years we're going to have much faster smart chains and blockchains.
Got it, thanks.
All right. Okay. Okay, Arthur.
You mentioned gas fees. Are those based on the network performance, or are they based on something else?
Do you mean how gas fees are calculated, or?
Yes, exactly.
Yes, it depends on some factors, but the main one, I believe, it's the load of the network. The higher the load of the network, the higher the price of the gas fees are going to be. So, for example, in the Ethereum smart chain, you have a lot of traffic. The nodes are working on a very intense pace, and consequently, the gas fees are a bit more expensive because the validators are working all of the time, and it costs more computational resources and more money to process transactions. So the gas fees are going to be higher as a consequence.
I see. Thank you.
All right. Okay, so let's move on. Let's see a brief history of the web, starting with Web 1.0. That goes more or less from 91 to 2004. I believe many of you know this website. It's the American Online, probably the first version of it. I'm not sure, but yeah. And we basically had mostly static pages that only had HTML. We didn't even have CSS at the time. So if you developed web pages before the year 2000, you know how limited and silly HTML was. It didn't have like 10% of the resources it has today. It's basically a read-only internet. You do not interact with content the way you do today. You can only basically view stuff, and that's it. You basically browse used to browse the internet to see information. Just that. The users were basically information consumers. They did not generate data or anything like that. A few more examples: the old Yahoo search, the MSN website, and the MySpace that many of us may know. All right, and the Web 3.0 that ranges from 2004 to nowadays. It's a completely different paradigm. It's interactive, it's personalized for each user, and it became kind of web applications became kind of a utility instead of browsing or developing websites. The focus starts to be on applications, on the development of applications and utilities, that you can use on your daily life. Desktop applications started to migrate from the local computer to the web. So this new model and this new concept introduced a lot of different possibilities. And a few more examples, but it also brought the age of targeted advertising, of course, because as companies now have the ability to track the user, to get information about the users, they use this information to give you special directed, targeted ads. So this is one of the ways that companies use your information, but there are many other ways. For example, let's use the example of Facebook. If I open my Facebook feed and you open your Facebook feed, they're going to look very different because it's a completely personalized experience. And it's only possible because of Web 2.0 and the technologies that it brought that allow this kind of tweaking on the user interface, and that allows basically the backend side of the application to know about the user and to prepare a different experience for the user. Not only the experience, but also, the ads. There's one slide in the middle, but my keyboard is freaking out. Okay. Not only the user experience, but also the targeted ads here. It's different for each user. Okay, Web 2.0 was made possible because of the evolution of web technologies like HTML, CSS, and JavaScript, but also the evolution of the web browsers themselves. And another key factor is the computing power available to end users, because many Web 2.0 applications are quite heavy to run, and if users nowadays didn't have powerful computers, it wouldn't be possible. So if you, for example, if you take Gmail or Google Calendar, for example, and you try to run it on a 486 machine, it probably is going to freeze and it's not going to work very well. A few more examples: Google Calendar, Google Drive are all examples of Web 2.0 applications. And one key characteristic of Web 2.0 applications is centralization. Because, for example, let's say the Google suite of application, it runs on the Google data centers, it's centralized, it's controlled by a single organization, that is Google, or in the case of Facebook, all of the data and the information about the users is controlled by a central company, you know, and that company owns the data, and they can do virtually anything that they want with that data. So if you don't love your data, be sure that Mark Zuckerberg loves it. All right, just again, just to make a comparison between the two models, to make it clear, in the centralized model, you have a central server, and in the decentralized model, you have a network composed by equal nodes that have the same weight, each one of them. Okay, and the Web 3.0. Let's see what are the differences between Web 2.0 and Web 3.0. Web 3.0 is basically an internet of value. It's a definition that you can see in many places when you talk about Web 3.0. Web 2.0 can be considered an internet of data and information, and Web 3.0 is an internet of value. It's basically composed by decentralized applications, as we talked before, or dApps, and it's more secure than the traditional model for the reasons we already talked about. It's fair and democratic because it's not regulated by a central authority or company. Most application use cases are very decentralized and democratic. And the role of the users on the network or on the specific applications and use cases is huge. The users have a lot of power and control over the platforms. Yes, again, it's controlled by its user, not centralized by tech giants or authorities. It's also censorship free because once information is on the blockchain, you just can't delete it. It's on the blockchain forever. Even if you try to tamper with the local node, it's not going to be replicated on the entire network. It's a read-only data storage. One of the huge use cases for Web 3.0 is what we call decentralized finance, which is basically financial services platforms that are not regulated by a central banks or governments. So it allows you to basically make investments, or there are many other different financial use cases for decentralized finance. We have right now we have an emergence of many different DeFi platforms, each one aiming to solve a very specific problem of the conventional financial market. And it's a very interesting thing to study and to get to know a little bit more. They are self-regulated. As I said before, it's not regulated by a central authority, although many governments, like the United States government, is trying very hard to regulate them, which made many of the decentralized exchanges to stop operating on the United States and trying to go to more free countries, which are less heavy regulation. and it empowers the users. As I said before, the user has a lot of power on the decision making and everything else. It's a win-win model. If you look at the model, the financial model that the banks operate, the bank never loses. You know, the banks always win. So if you think you're winning, the bank is winning more than you, for sure. And on the DeFi model, you have a win-win model because the user get the most value out of the platform, not the owners of the platform. So we not only have financial use cases for blockchain, smart chain technologies, but we also have many different use cases. You can implement virtually any platform using blockchain technology and the technologies associated with it. One great example is the Odyssey platform. It's basically a decentralized YouTube platform. It uses a very different storage file system. And it's decentralized by nature, so it's censorship free. You cannot take down videos. Some of you may think that this is a bad thing, but it depends on the point of view, of course. When you don't have the possibility to censor content or to take down content, you force the users to self-regulate and to create mechanisms to establish how you're going to deal with this kind of situation, with misinformation and, you know, the content that can damage others. The users self-regulate the platform. They come up with ways to get ahead of those problems. All right. So one of the great paradigm shifts that are probably going to happen in regards to Web 3.0 is the creation of decentralized autonomous organizations. They are basically organizations that are managed by the clients. As we can see here, a decentralized autonomous organizations, instead of having CEOs or presidents, they are controlled by the users, and the amount of influence that the users have on the decision making is defined by the amount of tokens of that specific DAO that the users have. So it's like shares. If you own a certain amount of shares or tokens from that specific DAO, you have more power of decision over the products that DAO implements or provide. The changes are made through voting by users. So let's say, let's give an example of the Facebook platform, for example. The shareholders are the biggest shareholders may not be part of the body of decision of the company. You know, you may hold a lot of shares on Facebook, but have no power on the decision making because they have a board of directors that make the decision. So in a DAO, it's very different. Everyone can vote on the decision making, and the censorship-free nature is another characteristic that is inherited from the blockchain technology. So just to point out, clarify a little bit the difference between each web version, I like this Twitter thread from Chris Dixon, where he says Web 1 was about open protocols that were decentralized and community governed. Most of the value accrued to the edges of the network. So these protocols are the HTTP, SMTP, FTP protocol. It was basically oriented around protocols and how people used those protocols. Web 2 is about siloed, centralized services like Facebook, Google, etc., run by corporations. Most of the value is accrued to a handful of companies like Google, Apple, Amazon, and Facebook. The value is in the hands of those companies, those centralized companies. And we are now at the beginning of the Web3 era, which combines the decentralized community governed ethos of Web 1 that was oriented towards protocols, and the advanced modern functionality of Web 2. Web 3 is the internet owned by builders and users and orchestrated with tokens. I would say with tokens and smart contracts. But that's a very good definition of each web stage. So how is the adoption of Web3 going to be? It's probably going to be a gradual process where maybe conventional companies like Amazon start allowing you to buy stuff with crypto, for example, buy gift cards or even products, send it to your friends, to your family, to their wallets, or even anonymously to other users. And those companies are gradually starting to adopt those technologies, and possibly they're going to be replaced by other decentralized solutions that are going to take their place on the technology scenario. So this is a very interesting graph that shows how new technologies are adopted over time. And we have 5 different phases here. The first phase is led by the innovators, the people that actually create those technologies. It's a very few people, and usually those people are very risk oriented. They're not afraid of taking risk and innovating, and they probably fail a lot before they can get it right. The second phase is the early adopters, the visionaries that they don't develop a lot, they don't create stuff, but they know how to recognize things that are promising or things that are going to work. And there's the early majority, that is the biggest slice. They're a little bit conservative, but they also take a look at what's going on, and they want to make sure that the thing is going to work before they jump in. There's the late majority, the second biggest group. They are very conservative. They want to see the thing very well established in order to start adopting it. And there's the laggards that are very conservative. They are very afraid of innovation. People who do not adopt something unless everyone else is already using it. So this is a very interesting graph on about how new technologies or breakthroughs are adopted over time. And this one is very important because there's this argument that the crypto and blockchain technologies are just, hype that is going to vanish over time. This is a graph this is a chart comparing the adoption of the internet and the adoption of crypto technologies. And as you can see, the time span here on the top is the internet adoption time span, and the one of the bottom is the blockchain adoption time frame. And you can see that the curves are very similar. So the rate of adoption of blockchain technology is the same, almost the same as the adoption of the internet itself. All right. Does anyone have questions before we go to the next topic?
Yes. Hi, Kaká. I'm thinking about, you said that the data is immutable in those blocks, right? So let's imagine that there is a hate speech video. Can it be erased?
Yes. It potentially depends on how the platform is implemented. Because, for example, the video itself is usually hosted on a decentralized file system like IPFS or other kinds of file system, decentralized file systems. So the video itself cannot be deleted because it's already replicated on the network, but the platform can unlist the video depending on how it implements the listing mechanism, you know? So this is a possibility. There may be other possibilities of content moderation, you know, but yeah, this is probably the best one. It's to control the listing mechanism in order to unlist unwanted content.
Okay, thank you.
Yeah. Right. Cassiano?
You said still concerned about the discussion about democracy and the ways of controlling the network and that's all the things you said about about the control. Is there a discussion about how the money can control it? Why I'm saying that? Well, besides it's distributed and the ways of distributing it's more difficult to control, to be controlled by the huge companies. We know that with some money and some technologies, with AI and robots, you can be many people on the internet. Is there any discussion about these ways of controlling with money on this kind of technology? You know, besides the difference of Web 2.0 and 3.0, we know that after some evolution of the technology, they can't do it to control with some money. Is there any discussion about it?
Yes, there's a lot of discussion going on, especially on how big players can start controlling decentralized projects. You know, this is a problem that is becoming very common because, of course, big enterprises, big companies are starting to see the potential of the blockchain technologies, and they're trying to buy a big share of certain projects, certain blockchain projects before they blow. You know. So this is a way of controlling how those projects are going to work in the future. It's by buying a lot of tokens of that specific DAO or of that specific project. So it's kind of generates a distrust on the specific project if a big player starts, for example, buying a lot of tokens of that project, and it's going to be naturally put aside by the community in the end. I believe that's what's going to happen, because if the community as a whole really wants a decentralized and user-controlled platform, they're not going to adopt a platform that is controlled by a big company or enterprise, you know?
I don't know, even that can be hidden, it can be hidden. I don't know. Or not?
No, because it's very transparent. Everything that happens in the crypto market is known by everyone, practically. It's a very transparent mechanism, a very transparent network. So if you have, for example, big whales that retain a lot of tokens of a specific project or platform, people are going to find out who they are, you know, one way or another, although it's anonymous in nature. Yeah, it's anonymous but transparent. Yeah, that's right. Right, guys. Just so we can, just so you don't, yeah, okay. Just so you don't take a lot of time, we're going to try to give some at least 10 minutes in the end, so you guys can ask more questions. But let's move on. Yeah, decentralized. Let's talk about development itself. We talked a lot about the technologies, but let's try to talk at least a little bit about the development aspect. which was supposed to be the main subject, but I didn't know that the rest of the talk would take so much time. But yeah, talking about the tool set that we use to develop decentralized applications, we basically use Truffle. That is a toolkit. You can see here on the GitHub repository. It's basically a CLI. The main tool of the suite is a CLI that allows you to create smart contracts, projects, and develop smart contracts, and build and deploy those contracts. It's kind of the core of the web of the blockchain development toolset. We also have Ganashi. Ganashi is basically a local blockchain that you can run on your own computer. And I'm going to show it running here on my computer. You basically have an entire blockchain. You can see the blocks here, their numbers, the operations that each block has. My computer is a bit slow right now because of the presentation. But yeah, you can see the contracts that are deployed to the network. For example, this is a contract I've been working on. And you see events that happen on the blockchain. You have logs that you can monitor the execution of your contracts and so on. This is a very nice platform or tool because it's very hard to connect directly to a blockchain node and develop stuff. So you need to have your local blockchain. Another one is the Web3 Library. So the way you call your smart contract is by using the Web3 library. It's a library that you can use on your React project, for example, or any UI framework or library that you use. It's basically how you can communicate with the blockchain from inside of a web application. You know, this is not the only way, but the Web3 library is by far the most popular one. If you see at the GitHub repository, it has 13K stars. It's very famous and it's the most used library. And about languages, which languages do you use to develop smart contracts? The most common language is Solidity, and the documentation of the language is great. You have a lot of examples, especially here in this section, Solidity by example. You have a lot of different examples on how to do different things. And I'm going to show you guys how a project looks like. This is a project I've been working on lately. This project was created by the Truffle CLI, the first tool that I showed you guys. And it creates a scaffold of the project. It creates the contracts, migrations, and test directory. So here you have the smart contracts. The smart contracts is just a code file here. The source code of the Solidity language looks a bit like the C# language. And this is the most similar language that I can think of. It has a few different concepts, considering that the blockchain is basically a distributed state machine. So the way you use data structures and how you manipulate data is a little bit different from the conventional development that we are used to. But basically you have the contract that looks like a class, where you have methods, structures, you have data fields here. And those data fields are basically the state of the contract. Every data structure that you declare inside of the contract is going to reside inside of the blockchain, you know. And to modify the state of this data, you need to pay fees. So every operation that changes data on the blockchain, for example, if I want to change this or to insert a specific item inside of this mapping or change any data that resides on the blockchain, I need to pay a certain fee. Sometimes it's very small, sometimes it's practically zero, but every operation that changes data inside of the blockchain needs to pay a gas fee. But that's not the only way. You can have methods that only read information from the blockchain. For example, here we have some of them. These methods use the view keyword to make sure to denote that the method doesn't change the state of the blockchain. And those calls are basically free. Instead of calling a transaction, you call the method, and the method returns specific data. So this is what a smart contract looks like in the Solidity language. How do we compile a smart contract? Here you can see I ran a test, and it's a very important aspect of smart contract development. It's a bit different from, for example, developing a web application that you can run and test immediately on the browser. To test a smart contract, you need to use preferably the test suite. So it's a very task-oriented development. So whenever I develop a new method inside of my contract, I'm going to create a test to test and to validate that method. And whenever I complete my tests and I'm satisfied and I want to deploy the project, I'm going to perform truthful deploy. My keyboard is just crazy. I don't know why. But basically the command is truthful deploy, and it's going to deploy the smart contract to the blockchain. And once you do that, you're able to see the contract here on the blockchain. So all right, I'm going to open for questions, but first I'd like to show you guys that this project is hosted on GitHub. My intention initially was to have a complete project that was basically an RSVP platform where the users can confirm the presence on specific events. They stake their tokens on the event, and if they don't show up, the tokens that they staked are going to be shared between the people that showed up. So it's a very interesting project. I didn't have the time to finish, but changing a little bit the approach, I'd like to ask you guys to help me on this project. And it's a great opportunity for you guys to learn and to apply what you guys learn. If you are, for example, a front-end developer, no problem. You don't need to work with smart contracts directly. You can use the Web3 library to call the smart contract, and you can implement the UI of the project, for example. I'm going to paste the link to the repository. Just a moment, and then we can open for questions. I'm going to paste the link on the chat here. Okay, you guys can start asking questions. The computer is really slow.
Hey, Kaká, it's me again. I have one question for you. From the perspective of someone who has already been a leader, a kind of a manager of a team, don't you think that blockchain is a complex concept? And I'm questioning this, thinking about over-engineering some use case where data centralization isn't a big deal.
I'm not sure I understood your question.
Like, for instance, the client-server architecture is something that's very normal these days, and almost every junior developer understands and can help to mount this infrastructure. But when you're working with blockchains, you have a new architecture that not everyone understands well, and we still have a lot of points that community haven't asked yet. So my question is, isn't the blockchain something that's going to be like related to specific use cases instead of a next step to the web development?
Yes, for sure. It doesn't solve all of the problems. For example, uh, every use case that requires a big storage capacity, for example, a video platform like we saw before, it requires you to use different services to store data. The blockchain can only run contracts that perform computation, preferably perform computation and save a very limited amount of data, but for sure, it doesn't apply to every use case, and we are yet to see which use cases are going to emerge. The community is working a lot on the implementation of new use cases, testing what's going to work, what's not going to work. We don't have all the answers right now. We have very interesting use cases that worked and that are a huge success, like DeFi, for example, decentralized finance, something that we could not even think about a few years ago, like 5 years ago. How can you have financial institutions that are not controlled by governments or big banks and that work, that are worth trusting, and where the users have the power to, make changes and influence? It's very interesting use case, but yeah, it's not for every use case.
Thank you, Kaká, and congrats on your presentation.
Nice, thank you. Okay, let's see who's next. Thales, Pimentel. Thales?
Yes. As I remember, you said that decisions could be made by the majority of the votes, right? And decisions to change anything in the blockchain. And my question is, are these votes unique per person, or maybe a person, a company may have 1,000 votes, for example?
Yeah, the more tokens you hold, the more influential you're going to be. So it's basically, imagine that on a conventional company, you have a board of directors. Each one holds a certain amount of shares. And the decision making and the influence that everyone has on each one of them has on the decision making is based on the amount of shares that they hold. It's basically the same thing, just the difference is that you don't have a board of specific stakeholders that make the decisions. The decision is made by everyone, and it's based on the amount of shares that each of the persons have.
Okay, thank you.
All right. Okay, Tarek?
Yes, hi, Kaká.
Hello?
Hello, can you hear me?
Yes, sure.
Yeah. So thank you for the presentation. I just wanted to ask a couple of things. One is like now when you want to deploy your contracts and, on the, I think you have to use some gas. You need to pay some gas fees, right? Like to deploy that, right?
Yes.
And for example, aren't you, for example, worried about now these days with, let's say, with the quantum computing and all this sort of stuff, like someone from altering this whole network of, the whole blockchain, especially these days, how powerful the computers are becoming, especially for a small project like, let's say like this project is still at the beginning.
Yes, that is a valid concern, and some big players on the crypto market are already talking about that. But the feasibility of something like that is very, questionable, because to make permanent changes on the network, you would need to replace most of the nodes in the network. It's like, I thought of the example of a botnet, but I don't want to use that example, but it's basically the same thing. When you want to take down a botnet, you need to take over most of its nodes. You know,
Yeah.
and sometimes it's a very difficult work because you have thousands and thousands of machines on the network. It's the same thing with the blockchain. It's very hard to get control of all of most of the nodes on the network. So I don't think that is feasible right now. And to be honest, I don't know how quantum computing is going to influence on this kind of approach.
Okay, thank you. I'll let the others ask questions. Maybe we'll chat later on if you're available.
Okay, sure. You guys can reach out to me to talk about anything. Feel free.
So actually, we are out of time because for the TechWeek event is a sharp end, but we can always continue the discussion on the AC Hub. I just posted the link here. So Augusto and Thiago, if you don't mind, you can post your questions on the link that I sent you on the chat. And then we can work with Kaká and have your questions answered and continue the discussion on AC Hub. Okay? Okay, so thank you so much, Kaká, for the presentation. I think it was really great. Like personally, blockchain is something that I always have struggling understanding, and I think your talk was really good for me to get some understanding on how it is, how it works, and what's the future of it. So thank you very much. I want to thank everybody for the attendance on our second day, and we can continue the discussion on AC Hub. Thank you very much.
Nice. Thank you, guys.
Kaká.
Thank you, guys. Thank you very much.